Okay, another quick video, this time on reactivity of the elements in different groups of the periodic table. So I'm going to look at group 1 and group 7 because these are at opposite ends of the periodic table. So if we look at the group 1 elements, I've just chosen lithium and sodium. These are at the top of the group. Now in group 1, the elements get more reactive as you go down the group. So we need to look at why that happens. So if we compare these two elements, both have one electron in their outer shell. Now all elements want to be stable, which means they have to have a full outer shell. So if we look at group 1, you've got to ask yourself, is it easier to get rid of this one electron, or is it easier to gain 7 to make this outer shell full? Well, of course, it's actually easier to lose that one electron, so it is left with an outer shell underneath. So why do they get more reactive as you go down the group? That's because of the distance that the electron is away from the nucleus. So if we have a look at lithium, the negative electron is relatively close to the positive nucleus, which is attracting it. If you look at sodium, the outer electron is further away from the positive nucleus, so the electrostatic force between the two of them is less than in lithium. So it's easier to overcome that force and lose this electron than it is to overcome the electrostatic force between the positive nucleus and the electron in the lithium. So sodium finds it easier to lose that electron than lithium, so it's more reactive. Now if we compare that to the group 7 elements, the opposite thing happens. The elements get more reactive as you go up the group, and you think, well, I wonder why that is. It's because, once again, the elements want to become stable and fill their outer shell. So if we look at fluorine and chlorine, you've got to ask yourself, what is easier? Is it easier to lose all 7 electrons to reveal a full outer shell underneath, or is it easier to gain 1 electron and complete the shell that they already have? Well, of course, it's easier to gain an electron. So why is fluorine more reactive than chlorine? Again, it's to do with the position of the electrons relative to the nucleus. So this position here in fluorine, where it wants to fill that gap with an electron from another element, is closer to the positive nucleus. So the electrostatic attraction is much greater here because this empty space is nearer to the nucleus. Whereas if you look at chlorine, the empty space is much further away, so the electrostatic force between the nucleus and this position is much less, so it's actually less attractive to an electron than this position is. Fluorine has a greater attraction to the electrons, so it's more reactive.